Okay, we're going to continue, and they just want you to practice some more factoring by grouping and various other methods. Sometimes you can notice patterns, sometimes you can't. Write the polynomial equation whose roots are the zeros of the part 1 and part A. So we're going to just try synthetic division, and we're going to note at the end, to get 42 we're probably talking something like 3 or 4. So we're just going to start with 1, but I don't have a lot of hope that it'll be 1. And if you don't know what I'm doing, watch my other videos. No, it's definitely not 1. It's not going to be minus 1 either. So let's just try 2. Keep that. We'll jump straight to 2. Could be minus 1. We're going to discover the other roots as we find 1. Well, so we're going to start with 2. 2 times 2 is 4. Add them together is minus 13. 2 times that is minus 26. Add them together, we're getting minus 3. Multiply, we got 6. And I would try minus 2 normally, except I think we're just going to jump straight to 3. Let's see what we get with 3. Okay. So bring down the 2 times 6, 3 is 6. Add them together, minus 11. Multiplied by 3, minus 33. Which makes sense because we're going to need a negative number in the final one to get anywhere. And we get minus 10 when I multiply by 3, minus 30. So very close with the 3. Let's jump to 4. And I'll just, there we go, I'll do it like this. Here we go. 2 times 4, 8. Add them together, minus 9. Times 4, 18 minus 36. I think we're going to get it here. We get minus 13. And times 4 is 52. So we're gone too high. So I'm just going to check my numbers. 8. And together, made a mistake right there. Oh no, I didn't. Minus 9 times 4, 8, 36. Add them together, minus 13. So we're really looking for, I'm going to go back to 3, and I'm going to try minus 3. Okay, minus 3. So 2, minus 6, minus 23. Times minus 3 is, oh boy, 69. Yeah, add them together. I'm way off base with minus 3. I'm going to try minus 2. Minus 4. Minus 21. 42. Add them together. 65. Way off. Trying minus 1 again. Just making sure it wasn't something simple. That shit's minus 1 after all. So you should always start with the simplest. Yeah. Should always start with the simplest. So we're left with this. I'm going to do the formula. X squared plus 42. And I immediately see I can factor 2 out of that, which I probably should have factored in the beginning. And I'm left with minus 18. And 21. Which means I'm looking for a number that adds up to 21, or multiplies up to 21 and adds up to minus 18, which is 3 and 7. No. 21 and 1. I think it's going to be minus. It's got to be 2 minus numbers. oops, what did I do here? I did not write down the correct numbers here, so I cannot factor out. My bad. It's actually minus 19 here, so I cannot factor that out. Okay, which means I'm looking for, it still doesn't matter, I'm looking for two numbers, and let me put them all back and forget about this, really fumbling around this one. I'm looking for two numbers that add up to, and this is a 2 here, they add up to 84. They multiply out to 84 and add up to minus 19. So if you look at 84, you look at 84 and 1, 42 and 2, 21 and 4. And that's close. It adds up to plus 81 and adds up to. So they're both going to be negative numbers. And so from that point, if I divide this by 3, multiply that by 3, I get 7 and 12, which I think works. 14 and 70, yep. And two negative numbers, that makes minus 19. There we go. Now I can use the slip and slide method, and I get x minus 7, x minus 12, minus 12, and the number in front is 2. This can't be simplified, so it's 2x minus 7. And the other one, minus 12 divided by 2 is minus 6. You can verify that you get the right numbers, especially after fumbling around. That's 2x squared, check. Minus 12x minus 7x is minus 19x, and plus 42. And that's what I want. So that's definitely the equation. And these are the roots, the zeros, which is what they're asking for, the roots. There you go. Which means what we have here is a cubic that has a positive leading coefficient that goes through the numbers minus 1, 0, 3.5, 0, and 6, 0. It's going to come up. It's going to go through the y-axis of 0, 42, come down, come up, and go shooting off. So this part here is going to be much higher, and then it's just barely going to come down to about like minus 12 here. So there you go. Explain how you can solve this in two different ways. Well, first, no matter which way you do it, you need to put all your things on the same side. We're going to put it all on this side to keep the x to the 4 positive. So x cubed subtracted over here makes minus 3x cubed. So I'm going to get x to the 4 minus 3x cubed. When I bring this 12x squared minus over here, it's going to be minus 25x squared. And the number minus 4, oh wait, let's do the x. When I bring the minus 21x, there's no 21x over here, so it just becomes minus 21x. And finally, when I bring the minus 4 over, it becomes plus 4, it cancels out with the existing number. So I'm going to get this. 4, 3, 2 is equal to 0. And that's just putting everything onto the same side. So that's the first step. Second step is I'm going to factor out. You can do two ways here. You could try to factor by grouping this group with that group. Or you could take the x out first, and you're going to bring it down to a cubic, and then you can try then too. Let's try taking the x down, because they each have x in them. And they don't have a common number, so I'm left with x cubed minus 3x squared minus 25x minus 21 is equal to 0. That's what I have. Now, I can see that I have x squared common here. I'm going to be left with x minus 3. And there's nothing really common there. So there's not going to be factored by grouping. At this point, you could try synthetic division. Well, you have to try synthetic division, I think, if you can't factor by grouping. You want to make sure you can't factor by grouping. No. they're not really divisible by anything. You could try rearranging them. You'd get x minus 25 and x minus 7, or plus 7. So factor by grouping doesn't really work here. And it won't work there either. Geez, I don't know what second strategy you would use other than synthetic. You could try long division, I suppose. Let's see what they say as far as two strategies goes. And it's right here. Graphically, they're saying is one of the solutions. Well, okay, I guess, yeah, you could plug it into a graphic calculator and figure it out. Let's do it the long way. We're going to take this, put it aside, and we're going to write down the coefficients here. 1, minus 3, minus 25, and minus 21. We're going to bring it all back up to here. And we're just going to do synthetic division instead of substituting in. I'm going to start with 1, bring this 1 down, times 1, 1, add them, multiply by 1, add them together, minus 27. No, 1 is not one of them. Okay, so you try it again with minus 1. And same thing, you bring the 1 down, this time you get minus 1, this time you get minus 4. Multiply by minus 1, you get 4, add them together, there we go, you get minus 21. And when you multiply, you get positive 21. So there we've discovered that x plus 1 is a factor, leaving x squared minus 4x minus 21. So you're dealing with a positive and a minus number, and you're dealing with 7 and 3. So x minus 7 and x plus 3 are the two factors of x squared minus 4x plus minus 21. And there you've come up with the polynomial equation. And if you were to write down the roots, it would be 0, minus 1, 7, and minus 3. If you were to draw this, you will discover that graphically Desmos would have shown you the roots, and that it goes through minus 1, and it's a quartic, so it's going to come down, go through minus 1. It's going to go up through 0, because that's what this x is. Going to come up, go down through 3, comma 0, and then down and up through 7, comma 0, and then go all the way up. And this little bump's going to be much smaller than this bump, and this bump. There's no y-intercept, because it goes through 0, comma 0. You could figure out a couple values here. You could always do between 0 and 7. Or did I get those things wrong? Goes through minus 1, 0. Yeah, I did get those wrong. Goes down through minus 3, then up through minus 1. So it comes down through minus 3, yeah, up through minus 1, down through 0, 0, and then up through 7. So this bump's going to be much lower. You could take 3.5 and put it into the equation to see. That's not the equation, by the way. There you go. Let's see if we got it right. Did we get it right? Nah, I'm pretty sure we got it right. I'll let you check. That one isn't that mysterious to me. To determine the zeros algebraically, verify your solution with graphics. Okay. Notice that they all have an x. Notice they can't be divided by 2, but maybe they can be grouped. So this one I can't take anything out. I'd be left with x minus 11, 2x minus 11. And this one I might be able to take. I'd have to figure out all the factors of 156 to see if, and I don't think it can. So I think I'm going to have to use synthetic division. But first I'm going to take an x out, and I'm left with 2x cubed minus 11x squared minus 37x plus 156 cubed, squared, and I forgot an x here. If you take their coefficients, now that obviously that 156 is going to be our problem one. So that means 1 is probably not going to be a solution, but we'll start with 1 because I made that mistake in the very first one. And I find synthetic division faster than plugging it into the equation. That's just me. If you have a good with a graphics calculator, you should just plug it into the graphics calculator and see if you get 0. Now obviously 1's not going to work, but let's try minus 1 just in case. 2 minus 2, you get minus 13, which means you get plus 13 here, which means you get 24. No, that's not going to make it. I think we're going to be dealing with something like 3. We'll come back to 2. Let's try 3 right away. Three times that is indeed, and that's a negative here, 3 times that is indeed negative 156. So now that I found 3, it's going to be a lot easier for me. So x minus 3 is 1, because that leaves 2x squared minus 5x minus 52 as the quadratic function. Don't forget the squared, which means I'm looking for a number that multiplies out to positive 104 and adds up to negative 5. Now, that means there's going to be, negative 104. That means it's going to be a positive and a negative number, and they're going to be very close to each other. So you should look at the square root of 100 is 10. So we're looking to see if it's going to be divisible by 9. It's not. Divisible by 8 it is. It's 8 and 13. And you'll notice those are 5 apart. So it's going to be plus 8 and minus 13. 8 times that will make 104, minus 104, and add them, I get minus 5. So that means using the slip and slide method, we're got x plus 8. Let's get rid of those. Got x plus 8 as one root, and x minus 13 as the other. And the number in front is 2. Well, x plus 8 can become x plus 4, so that means that's that one. And the other one can't be divided by 2, so you slide it in front, and you get 2x minus 13. Now, whenever you do the slip and slide method, it doesn't hurt to do a quick check to see if you got the quadratic you wanted. So, sure enough, 2x squared minus 13x plus 6x, plus 6x minus 13 plus 6x is minus 8, not minus 5. Let's check that again. Minus 13 plus 8. No, that's minus 5. So it's minus 13 plus 8. Yeah, got it. And then 4 times that is 452. Got it. So that means the zeros are in order. 0, minus, in order actually, minus 4, 0, 3, and 6.5. Since we're dealing with a quartic that has a positive leading coefficient, and it doesn't have a y-intercept, it's going to go through minus 4, 0, 0, 0, 3, 0, and 6.5, 0. And it will look like this. idea. This bump will be a lot smaller than that one. This one will be about the same, but a bit deeper. How do I know 3 to 3.65 will go down further than this one here will go up higher? It's because the distance between this is 3 and the distance between this is 3.5. And then, of course, they keep going forever here and keep going forever here because that's what quartics do. So this is what I should see. I think I'll see a very much lower number here than here. This will be the second lowest, and this will be the third distance from the x-axis. So let's try this. It is 2x to the 4 minus x cubed. Uh, 2x to the 4 minus 11x cubed minus 37x squared. And the last one was plus 156x. Hopefully I wrote that down right. There's the minus 4, there's the 0, there's that, there's the 3, and there's the 6.5. Sure enough, this went down further. This went down second most, 5 down, or 273 down. Wow, it's way down. And then this went up 123. So you can see those numbers are crazy big, how far it dips when the space between the x-intercepts is wide. But relative, I got it right. This one's the lowest, this one's the second lowest, and this one's the third distance from the x-axis. And we got all the x-intercepts right. And continue. Now that you're done practicing, or warming up your factoring, they want you to practice the lesson. And that's using your knowledge to figure things out. So I'm going to just put this on a different page. Just going to minimize it, and I'm going to get rid of it. So roots are quite simple. It's whatever's in the brackets will be equal, we'll make the bracket 0. So the first one is just x, right? So it's just 0. Second one's 2. And the last one's minus 5. Those three things will make those brackets 0. X cubed is equal to minus 1. You might say, well, it doesn't have a root, but that's not true. The cube root of minus 1 is minus 1. So when x is minus 1, it cubes. It becomes minus 1. When you add 1, it's 1. So that's the first one, and the next one's 17. So you just make whatever's in the bracket equal to 0, and you solve for x. The next one doesn't exist. X squared equals minus 36. Doesn't exist. And the other one is 16 divided by 8. It's 2, so there's only one root there. For D, the first minus 3x cubed means 0 is a root. The next one, minus 4 over 2, which is minus 2, is the other root. The other one is x squared is equal to 25. When you square root both sides, you get minus 5 as an answer, and plus 5 as an answer. So those are the zeros for that. And then the middle one you have to solve. So a number that multiplies by minus 12 and adds up to negative 1 is x minus 4 and x plus 3. And then you got 3x there. So that means 4 minus 3 and 0 are the zeros for that one. So that was E. And they want you to do the same for F, but the first root has a minus 1. The second one, the root is x plus 1 squared. That's a perfect square there. So you'd have x squared, which means the only answer for that one is also minus 1. So really it should have been written as x plus 1 cubed. You notice they used the cube rule to come up with the second term, but the second term is factorable. So that means the only root for that one's minus 1, or the only 0. 0 and the roots are the same thing. There, it's what x value would it cross the x-axis. Okay, go on to the next one. This one they want you to use exactly what we were doing before and solve algebraically. You should always see if there's some easy tips. And I noticed the first one, when I divide both by 3, I'm going to get 30, x minus 30, and x minus 8 in the first one. So it's not factorable by grouping. So that means you should just use your synthetic division techniques or a calculator to see if the following are roots. So the first one would be 1. As soon as you discover a root, it makes things a lot easier. Nope. Go for minus 1, which I don't think will work either. It's just not getting big enough in the first couple. Nope. I can tell you already that's not going to work. So we're going to go to minus 2 now. Almost. Now, I can tell you right now it's going to be a minus number because we need to produce a minus in the last number to add to positive 90. So there's a little hint on how to do things. And minus 3 times 30 is indeed minus 90. So that means one of the factors is x plus 3. And I'm left with x squared minus 11x plus 30. A number that multiplies out to 30 and adds up to minus. So we're talking about two minus numbers. It's not 3 and 10, it's 6 and 5. Which means the roots are minus 3, 5, and 6 in order. So that's the answer to A. I'll just leave it like that. There we go. What about this one? Okay. Same issues, same techniques. First, see if you can factor something out in the beginning. Notice we're dealing with a lot of terms, x to the 4 all the way to the numbers. It doesn't appear that anything can be factored out. You can't factor by grouping unless you could somehow factor this one, but that's a hell of a factor to do. You have to come up with a number that is equal to minus. That might be possible. But anyway, don't bother. We're instead going to look at the coefficients. 1 might be possible, so we're going to start with 1. Yep, 1 is possible. So that means x minus 1 is one of the factors. So the root is 1. And we're left with this. X to the 4 plus 10x cubed plus 31x plus 30. Your first step is always to look to see if you can factor by grouping. You can't. You've eliminated 1, so you don't do 1 again, although 1 could conceivably be an issue again if it's squared. So we should check again for 1, just in case. So get rid of all the old factors, put in the new coefficients, and try 1 again. Okay. It's not. Okay, we're going to try, we want those coefficients back. We're going to try minus 1. Nope. You get 22. Doesn't work. I'm going to try, just for heck of it, I think I'm going to try -2 instead of 2. Nope. Oh, wait. Yep. So we're left with a new factor, which is x plus 2. They don't want the factors, they want the roots. So, and we're left with something that multiplies out to 15 and adds up to 8, because that's 1x squared plus 8x plus 15. And we're obviously got x plus 3 and x plus 5. So that's the other factors, which means the roots in order are -5, -3, -2, and +1. Should put them close in the first place. But there we go. That's the answer to B. And then you just continue on. That's the answer to B. You just continue on the same method, trying to make your life easier by factoring out anything you can. This one looks like it's going to be very like a x plus 1 cubed sort of thing. Okay. So we're dealing with the coefficients. Can we factor anything out there? It doesn't look like it. Coefficients here. Doesn't matter what method you use. Whatever method's the fastest, this is the one I would recommend. Nope. So we're going to try -1 now. I'm willing to bet -1 is one of them. Oh, no. Oh yeah, it is. Great. So we're left with x plus 1, and then 2x squared minus 7x plus 3x, which means we're looking at a number that adds up to +6 and adds up to -7. So we're looking for x. Well, you got to use the slip and slide now. X minus 6, x minus 1. You got to use the slip and slide. You divide them both by 2. You get x. You get it. The 1 can't divide by 2, so it's a 2 up here. The 6 can divide by 2, so it's a 3 right here. Which means these are the factors you can confirm by expanding it. Okay. Get rid of this stuff. Which means the roots are, in order, -1, 1/2, and 3. So we'll just bring this down, and we'll say C. Doesn't matter, we'll just say C is this. And remember, every time I want you to stop and try it and make sure you got the technique down. This one, they've put them all on the wrong side. So you've got to rearrange it. Essentially just change all the sides. To negative. And put a 0 on the other side. Okay, then you do their coefficients. You see if there's an easier factor to do. There's not. 3. We're probably dealing with 1 or -1 here because the numbers are so low. Start with 2, 2, 5, 5, 0. That doesn't work. Just ignore that. Crank call. So then we're going to try minus 1. Go down to 2. Minus 2. Add them together, I get 1. Minus 1. Add them together, I get minus 6. Multiplied by minus 1, I get 6. 6. That's supposed to be 6. And I just got to fix this back. There we go. I'll go with that one. Good. So that means I've got x plus 1 as one of the roots, as one of the factors, rather. 2x squared plus 1x minus 6 is the other one. So I'm looking for something that adds up to minus 12, multiplies out to minus 12, and adds up to positive 1. So I'm dealing with plus 4 and minus 3. If I do the slip and slide method, I'm going to discover that it's x plus 2, 4 divided by 2, and 2x minus 3 is the possible other one. Go ahead and expand that to make sure I got it right. But if these are the factors, which I believe they are, that means these are the roots in order. So we'll just put it over here. We'll go on to E. We're finally dealing with some big numbers here. It's again on the wrong side. So you simply put your equals here and change your sign here to minus to bring the 40 to that side. Can I factor anything out? Nope. So I'm dealing with 4, 4, minus 51, 106, and minus 40. We'll just start with minus 1 since it's already up there. No, not a chance. So we're going to move on to 1, which I don't think will work either. Closer than I thought. Let me make sure of the math. Yeah. Okay. So it's probably like 2. Since the last number's negative, it's probably 2. Nope. I'm going to keep those and get rid of these. So we're dealing with 2. So that is going to be, what is that, 27? Did I get that right? Yep, you did, I think. Yeah. Oh, this last one's 10 something, not a subtraction. So let's try minus 2. Oh, that's plus 9 over it, plus 8 over here. There we go. Nope. That should be right, though. That first one's not a subtraction, though. It's an addition. Oh, yeah. So 86. Yeah, I got the addition wrong. Let me try plus 2 again. I think I just got something wrong, but who knows? I'm going to try plus 2 again. No. Okay, let me try minus 2 again. You never know when you get tired. You make weird mistakes. Yeah, that's not it. Okay, let's try minus 3. Did none of these work yet? No, 8 minus 8. So 24, add them together, I get negative 27 times 3. I get positive 81. No. Let me check the formula and make sure I didn't screw up anything here. That's why you keep the original one. Yeah, I did screw it up. Screwed it all up right there. And it's even in the original. Right there. So I'm just going to separate my numbers a bit. Makes it a little bit better. There we go. Let's try it again. We got to start all over again, because if you don't use the right numbers, it's never going to work out. Almost. Let's try negative 1. Yeah, that just means negative 1. Nope. Let's try negative 2. Let's start with 2. There you go. Oof, long way for that one. So what happens when you use the wrong numbers? Anyway, I got 4x cubed plus 4x squared minus 43x plus 20. Okay, and you got to do it all over again. Okay. Let's start with this one. Get rid of that now. A lot of them are the same. And you do it again. Keep in mind 2 and minus 2 could still be factors if it's squared. So you should probably check 2 and minus 2 again. You just know 1 is not an option. Okay. I'm going to try 2 again. Nope. Minus 2. Nope. So we're going to try minus 3 or 3. Let's try 3. Close. Make sure I didn't get it wrong. 16. Plus 5, close. Maybe 4 then, but let's try minus 3. Nope. 4. Nope. Try minus 4. I don't have much hope here. So they're giving us some difficult ones in the end here. Maybe I screwed something up too. No, that's definitely not going to work. Oh no, it might. Neat. There we go. So that'll make my life a little easier. That means x plus 4 is a factor, which means I got 4x squared minus 12x plus 5 as the last one, which means I've got to have a number that multiplies out to positive 20, adds up to minus 12, which is clearly minus 2 and 10. And then when I do slip and slide, and it's x minus 10, by the way. And when I do slip and slide divided by 4, this simplifies to 1 over 2, 2x. And this one, 10 over 4, simplifies to 5 over 2, which simplifies to this. If you multiply that out, you'll discover you get what you want. There you go. So that's that root, which means the roots themselves are in, can I do it in order? Minus 4, 1/2, 2, and 5 over 2. So that's E. Then you got one last one. And I might have to stop again. There we go. Cubics are much easier, but remember we've got to put them all on the same side, so this becomes a plus. And this becomes a minus. And it all equals 0. Which means the coefficients I'm working with are 12 minus 44 plus 49 and minus 15. Start with the easiest ones, 1. Close. So close I want to check my math on it. Yeah. So we'll try minus 1. This is going to go off the rails. Yeah, that's not going to work. So we'll try 2. I don't know why it does that. Close, but no cigar. So we'll try minus 2. It's not even going to come close. Now it's going to create a huge number here. So I'm going to try 3. we're going to try -3. Don't think so. Going to create a huge positive number here, which isn't going to work. So we're going to try one last one. Hopefully it's -4. Hopefully I didn't screw anything up either. Actually, +4 is what we should try first. 2448. 16. And again, no way, Jose. So, -4. And again, a massive positive number. Oh, I'm running out of hope. Oh, was this one I should have factored by grouping? Doesn't. First one, 2 is 6 and 22. Not really. 3? No. Okay, one last try. 60. 16. Don't think this is going to work. Massive number there. I must have missed one. So that one I'm willing to say give up just because I'm tired. And just have a look at it. So, where was I? Algebraically. I'm at number 7, eh? Yeah, so -4 was one of them. So I screwed up the -4 somehow. Oh, no, that's E, which I already got. Yeah, oh, I had to try halves. I had to realize that that last one, go back and revisit the half one. See, they're all halves. So what I had to realize that it was going to be something like 15 over 12, which is here. And if you simplify these down to the basic roots, you're talking 3 over, well, you're talking 3 over 3, but 3 over 4. You're also talking about 5 over 2 and 5 over 3, which is that one over there. You're talking about 3 over 2, which is that one right there. And you're also looking at half, just half. So these would have been hard to figure out without first looking at the end numbers. So there's a spot in the chapter that discusses that. Right here, I think. But they never really use it. So, I mean, let's just pretend we try out the half and see what happens. And see if we would have figured it out. Makes sense that a half is because we're not achieving that last 15 number. Well, I still didn't achieve it. I wonder if I wrote one of the numbers down wrong. Oh, fake number. Well, I'm going to end it there. Sorry, I might do that one again.